Hi and welcome back to ScottiesTech.Info. I'm Scottie with my co-host Cletus, and today I want to talk about the amazing power brick and how you can probably save some money by learning how to replace one of these. You might think it's kind of easy. It's really not, as you'll see. Power bricks are used basically you plug this end in the wall. That takes 120, 230 volts AC alternating current, and it converts it to DC direct current and spits it out the little plug end. And these things are used to power pretty much everything. Like your laptop has a bigger power brick. They're used for Ethernet switches, such as this one, for example. This will be my sample gizmo. They're used to power all kinds of different gizmos, and the thing is, you'll be just using your gizmo and one day it will stop working. Or maybe it works but only part of the time, or maybe some of the lights come on, but it doesn't really do what it's supposed to do, and so you think, ah, crap, my gizmo's dead, and so then you chuck it in the recycling bin and you just buy a new one. And much of the time when a gizmo fails, it's actually this guy that's the culprit. Now you might think that diagnosing this is kind of easy because obviously if this thing is converting AC to DC, DC being of course just like a battery, well, you can take a voltage meter and you can stick your probes in there and you can say, well, it says it's supposed to output 5 volts or 12 volts or whatever, and you measure it and you see, yes, it is actually outputting 12 volts. So obviously that's not the problem, the gizmo is dead. But actually in reality, that's not quite adequate, because the way that these fail, they have some electronics inside, sometimes a little transformer. It just converts the AC to DC, it regulates the power, and very often when they fail, they will still output the proper voltage, but they won't output the proper amount of current. Now recall that voltage is basically like if you think of 2 buckets of water and they're connected by a tube. One bucket of water has a whole lot of water in it and the other bucket is nearly empty, and the buckets are connected by a tube on the bottom. So naturally water will flow from the bucket with more water into the bucket with less water. So the difference in the amount of water in these buckets is equivalent to voltage, i.e. the difference in potential, in this case the difference between the amount of water. And current is the amount of water, say, flowing through the tube past a given point in a certain amount of time. So voltage, difference in electrical potential, current, amount of electrons flowing past a given point. So the problem with these things is that when they fail, very often the voltage will be okay, but the amount of current that it can supply is inadequate. It's like it's supposed to supply 12 volts, 1 amp. You may construct a slightly more elaborate test setup using a meter if you know how to do that, and you'll discover that okay, it's giving me 12 volts, but instead of 1 amp, it's only giving me like, 10 milliamps or something, like a tiny amount of current, and so therefore your gizmo doesn't work. So it's handy to have a couple of these things just sort of sitting around the house, and when one of your gizmos dies, the first thing you can do is break out a universal power supply, a universal power brick, such as this one. Now, keep in mind, I'm going to show you this one and a couple others and talk a little bit more about some of the gotchas when you try to use one of these. Keep in mind that they're basically a dime a dozen. I mean, I have like Hama and Ansman or something. Yes, Hama and Ansman. These are the brands that I can find here in Europe easily on Amazon, on Conrad Electronics, whatever. I'll put some links in the description for various ones that I find are good, that are available both in the US and in Europe. You don't necessarily have to use those because, like I said, they're a dime a dozen. There are tons of manufacturers, but there are a few things you need to watch out for when you're purchasing one. So let me talk about that real quick. Okay, so the first thing you're going to do is, this is my sample gizmo. Let's say it's not working. This is my power brick. So the first thing I'm going to do is I'm going to look on here and I'm going to note that it says, you notice it says input 200 to 240 volts because this is a European plug. 200 to 240 volts. Usually it'll say input 100 to 240 volts, and you'll notice this little squiggly line there. That's the AC symbol. 50-60 hertz, 0.2 amps input. The part you really want to pay attention to is output. And here it says output 12 volts and you see this funky symbol with the straight line and the dashes. That means it's DC, direct current. So the output is 12 volts and 1 amp. And the final thing to notice is this little symbol here, which hopefully you can see, and that indicates that when you're looking at this guy, the pin, the center, the pin that goes in the center is positive, and you can tell because you see the little plus there with a circle, and the line is drawn to the dot in the center, and that sort of backwards C on the outside, that's got a little line over there to negative. So that means that this needs to be center positive, not center negative. You'll understand what the heck that means in a second. So we know we need a universal power supply that outputs 12 volts, that can supply 1 amp at 12 volts, and that is center positive. So then we break out our little universal power supply. Now, you'll notice that it says, here we go, out 3 volts, 4.5 volts, 5 volts, 6 volts, 7.5, 9, and 12 volts, and then it will say 1,000 milliamps, or 1 amp. You also notice on the back here that it says, see if we can, yep, I think you can read that. It says powerful max 1,000 milliamps across all voltage ranges. Now that's rather important because I have some other universal power supplies here, such as this one. This one is an Onsman. It's 5 to 15. This guy's kind of big. Now you notice here it's 5 to 15 volts. So you see you can configure it for 5, 6, 7.5, 9, 12, 13.5, and 15 volts DC. And it says max output current 2.25 amps. But then it says max output power 27 watts. Now, if you do some math, recall that power equals voltage times current. So if you do the math, you will quickly realize that if you take 27 watts and divide it by 15 volts, you only get 1.8 amps. So what that means is when you're buying one of these, you can't just say, oh yeah, I need one that supplies 15 volts and it says it does 2.25 amps and my gizmo needs 15 volts, 2 amps. So if you bought this one, it would not work. And the reason it would not work is because the max power is 27 watts. So very often when you buy one of these, whatever the max current is, you can't just look at that number. You have to look at all the different voltage ranges and do a couple of quick calculations and make sure that the amount of current you're going to get at the voltage you need is adequate. So for this one, since the max is 27 watts, 27 divided by 15 is only 1.8 amps. So if I needed a gizmo that required 15 volts and 2 amps, this would not be adequate. I could not use this one. At 13.5 volts, 27 watts divided by 13.5, I only get 2 amps, not 2.25 amps. And at 12 volts, I get 2.25 amps. So this device, for the voltages 5, 6, 7.5, 9, and 12, you get the full rated current, the max output current of 2.25 amps, or 2250 milliamps. But for the higher voltages, you don't get that max current. So that's the first gotcha. Hopefully that wasn't terribly confusing. Remember, whatever the max power is, either it has to be like this one where it actually tells you point blank, powerful max 1000 milliamps across all voltage ranges. That's actually the kind that you're looking for. These, yeah, you have to kind of do some calculations and make sure that you're getting one that's going to supply enough current. Otherwise, what's going to happen is you're going to get your replacement universal power supply connected up and go, ah, my gizmo's dead. When in fact your gizmo is not dead. The problem is that your new universal power supply simply can't supply enough current. Okay, so, but this one we know can supply 12 volts and 1 amp, and that's exactly what we need here, 12 volts, 1 amp. So we open her up, we get little plugs there. We don't need the box anymore. So now you're going to notice that when you look on this one, what you see Again, this is a funky European plug, but if you're in the US, you'll have them with an American plug, obviously. You'll notice you have this little wheel here, and the little wheel, you can turn it. It's 3 volts, 4.5, 5, 6, all the way up to 12 volts. So because for our little Netgear Ethernet switch here, we need 5 volts. So you take your handy little tool, and you just turn the little wheel, and there you go. Now it's going to output 5 volts. That's it. Okay, we've got the right voltage, but the next step is to take our dead Netgear supply, and we need a plug like this. Now, obviously you just take these and you kind of compare them, and you want to look and see, well, that one on the end, it actually looks pretty good. It's a little bit longer, but that shouldn't matter. So then you take that one, and you can do a little test and stick it in the back here. Does that feel like it's going to work? Yep, that seems to be like the right one. So then the final thing you're going to want to do is you look on the end of your universal supply here, and you see it doesn't actually have the plug because we just picked it right here. Now you'll notice if you look very closely on here, you can see it says center positive with a down arrow, and if I flip it over, that's center negative with a down arrow. And recall for our Netgear that we want a center positive. So then what you have to do is you look at this thing, and on one side, this is usually how they do it, on one side there's an arrow, and on the other side there isn't. So on the side with an arrow, you want to take this guy and say, okay, that's center positive, so I want the arrows pointing to each other. So I don't put it in this way, I put it in this way. And I'll show you that in a minute. These are often somewhat difficult to get in. So now, as you can see, we have the two arrows are pointing at each other, and it's center positive. So now we can plug it in, plug the brick into the outlet, and Bob's your uncle. It's working. The green guy's lit up, and he's ready to plug in computers so that you're not using evil Wi-Fi. Bing! Right, so in summary, you have to be careful if you're buying one like this and they give you a current rating and they give you a power rating. You have to be careful because unless it explicitly says, yes, I can supply 1000 milliamps or 2250 milliamps across the voltage range, then it may not actually work. So you're going to have to actually look at more than the voltage. You have to look at the voltage, say 12 volts, the current that's required, say 1 amp, and then also is it center positive or center negative, and plug it in, and Bob's your uncle. One final note about these power bricks is occasionally you'll have a gizmo where instead of being an AC to DC converter, it's actually just AC to AC. And you'll be able to tell because you'll see that little symbol that I showed earlier. Instead of 12 volts DC, the line with the little dashed lines under it, that's for DC. Instead it will say output, say like 9 volts. Sometimes it will say 9 volts AC, sometimes it will just say 9 volts with a little squiggly line, a sine wave after it. And that means that that power brick can't be replaced by one of these universal ones like this, because these are AC to DC converters. So they're fairly rare. I've seen them used on AC to AC power bricks. They're used on certain things like, you know, AT&T telephones, like desk phones and some things like that. But just in case, watch out for that as well. So that's pretty much it. If you haven't actually visited my Teespring store, I have added 3 new shirts. You can get them as shirts and phone covers and coffee mugs and all kinds of other stuff. I have a bunch of stuff on there. I just added this shirt and this shirt and this shirt, which are also available on, the design is available on other products. I'll put a link at the end of this video and also in the description. If you want to go shopping and buy some Scottie stuff, please do, because I don't actually make a lot of money from my YouTube videos or from my the ads that are on my website. And so selling merch is kind of a nice way where you actually get something, and then I make a little money and it helps to support me, and then I'll make more videos. So check the description or link at the end of this video. Check out my Teespring store. Buy some stuff if you want. Support my channel. like, subscribe, notifications, all that other stuff. And that's it. So, for more techie tips, see ScottiesTech.Info. Thanks for watching. See you next time.